Exercise 8.3 Trigonometry NCERT. Question 1. Express the trigonometry ratios sin A, sec A and tan A in terms of cot A. We know that cosec square A minus cot square A equal to 1. We know also sin A equal to 1 bata cosec A. Cosec A equal to 1 sin A. We can write here cosec square A 1 plus cot square A. We can write here 1 sin square A equal to 1 plus cot square A. And now we can write here sin square A 1 bata 1 plus cot square A. This is first question. Sin A barabar 1 bata 1 plus cot square. Now we solve sec A. We know that sec square A minus tan square A equal to 1. Sec square A 1 plus tan square A. We know that tan A equal to 1 bata cot A. Now sec square A equal to 1 plus 1 bata cot square A. Here sec square A, now LCM cot square A, cot square A plus 1 sec A equal to under root 1 plus cot square A divided by cot A. Second number is this sec A equal to under root 1 plus cot square A divided by cot A. Now I will solve tan. Tan A, we know that 1 bata cot A. Finish this one first number question. Question number 2. Write all the other trigonometry's ratios of angle A in terms of sec A. We need first sin A. Answer. Sin square, we know that cos square A equal to 1. Now sin square A 1 minus cos square A. Sin square A, we know cos A equal to 1 bata sec A. Sin square A, I will write here 1 bata sec square A. Sin square A equal to sec square A LCM. Here sec square A minus 1. Now sin A under root sec square A minus 1 divided by sec A. This is one answer. Cos second given cos A 1 by sec A. Now tan sec square, we know that sec square A minus tan square A equal to 1. Here tan square A equal to sec square A minus 1. Here tan A sec square A minus 1. Now cot in terms cot A equal to 1 by tan A. Cot A equal to 1 bata sec square A minus 1. Cot also free. And now here cos sec A equal to 1 bata sin A. Cos sec A sin value is here above proved. Here put sin value sec square A minus 1 divided by sec A. Cos sec A sec A divided by sec square A minus 1. It is proved. Question 3. Choose the correct option. Justify your choice. First, 9 sec square minus 9 tan square A. Option A1, B9, C8, D0. Now answer this question. First, 9 sec square A minus 9 tan square A. We know that sec square A minus tan square A equal to 1. Here we take common 9 sec square A minus tan square A. Put the value 9, 1 here, and answer is 9. Option B is correct. Now, second question. 1 plus tan theta plus sec theta. 1 plus cot theta minus cos theta. Option A 0, option B 1, option C 2 and D minus 1. Now solve this one second. 1 plus tan theta plus sec theta. 1 plus cot theta cosec theta. Now sin theta divided by cos theta plus 1 bata cos theta. 1 plus cos theta sin theta minus 1 bata sin theta. Here LCM cos theta plus sin theta plus 1. Now LCM sin theta plus cos theta minus 1. Here cos theta plus sin theta square minus 1 square divided by sin theta into cos theta. Here sin square theta plus cos square theta plus 2 sin theta into cos theta minus 1 divided by sin theta into cos theta. We know this 1 plus 2 sin theta into cos theta minus 1. Here sin theta into cos theta. 1 cut here. 2 sin theta into cos theta divided by sin theta into cos theta. Cutting here. Now answer is 2. Option C is correct. Now question third. Sec A plus tan A 1 minus sin A. Sec A plus tan A 1 minus sin A. Here 1 bata cos A plus sin A bata cos A. One minus sin A cos A 1 plus sin A. 1 minus sin A. Here 1 minus sin square A bata cos A. Here cos square A divided by cos A. Answer cos A. Option D. D is correct. D is correct. Now question 4. 1 plus tan square A divided by 1 plus cot square A. Option sec square A, B minus 1 cot square and D tan square. Now we put the value 1 plus here 1 bata tan square A. Now 1 plus tan square A, tan square A plus 1 divided by tan square A. Now 1 plus tan square A, 1 plus tan square A, tan square A. Here cut this one, tan square A. Tan square A means option D is correct. Question exercise 8.3. Prove the following identities where the angles involved are acute angles for which the expression are defined. Now we will solve this one. Solution. We will take left hand side. Cos sec theta minus cot theta square. We will write here 1 by sin theta minus cos theta bata sin theta. Here whole square. We will take LCM sin theta. Here 1, here cos theta. Here 1 minus cos theta whole square. Now sin square theta. Now we can write here 1 minus cos theta, 1 minus cos theta. Here 1 minus cos square theta. Here 1 minus cos theta, 1 minus cos theta. Here 1 minus cos theta 1 plus cos theta. Now we use here a square minus b square here. A plus b, a minus b. Now here cutting this one. Here 1 minus cos theta divided by 1 plus cos theta. Here LHS equal to RHS. This is proved. Question. Prove the following identities where the angles involve acute angles for which the expression are defined. Question second here. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A equal to 2 sec A. Here solution here. LHS cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. Take LCM 1 plus sin A into cos A. Here cos square A plus 1 plus sin whole square. Now cos square A plus 1 plus sin square A plus 2 sin A. Now 1 plus sin A into cos A. Here sin square A plus cos square A plus 1 plus 2 sin A divided by 1 plus sin A cos A. Here 1 plus 1 plus 2 sin A divided by 1 plus sin A cos A. Now 2 plus 2 sin A divided by 1 plus sin A cos A. Here common 2 sin A 1 plus sin A cos A. Here cutting 2 sec A. Proved LHS equal to RH Yes, finish. Question. Prove the following identities where the angles involved are acute angles for which the expression are defined. Question 3. Tan theta divided by 1 minus cot theta plus cot theta 1 minus tan theta equal to 1 plus sec theta into cosec theta. Now we will change here solution. LHS tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta. We will change here sin theta divided by cos theta 1 minus cos theta divided by sin theta. Here cos theta divided by sin theta 1 minus sin theta divided by cos theta 9 theta divided by cos theta. Here sin theta minus cos theta divided by sin theta plus cos theta divided by sin theta minus cos theta minus sin theta divided by cos theta. Now sin theta divided by cos theta into sin theta divided by sin theta minus cos theta. Here cos theta divided by theta into cos theta minus sin theta. Here LC square theta divided by sin theta minus cos theta. Here cos theta minus cos square theta divided by sin theta minus cos theta sin theta. LCM here I will take here sin theta. Now this minus cos is also plus. Sin theta minus cos theta. Here cos theta into sin theta. Sin theta is cutting, cos cutting here, sin theta minus sin here cos cube theta. Now sin theta minus cos theta. Here sin square theta plus cos square theta plus sin theta into cos theta. Here sin theta minus cos theta cos theta into sin theta. This is here cutting. Here 1 plus sin theta into cos theta divided by sin theta into cos theta. Here sin theta into cos theta plus 1. Now this opposite 1 plus sec theta into cosec theta. Formula we know a cube minus b cube, a minus b, a square plus ab plus b square. This algebraic formula I use here. Now LHS equal to RHS. Finish. Question. Prove the following identities where the angles involved are acute angles for which the expression are defined. 1 plus sec A divided by sec A equal to sin square A 1 minus cos A. Now we will solve this one. Solution. We will take right hand side sin square A divided by sin cos A. Now sin square A equal to 1 minus cos square A. We know this one. Now here 1 minus cos square A divided by 1 minus cos A. Here 1 minus cos A 1 plus cos divided by 1 minus cos A. Use this formula. A square minus B square. A plus B. A minus B. Now this is here 1 minus cos A here. This one. Sorry, here 1 plus cos A, cutting this one. Here 1 plus cos A. Now 1 plus 1 bata sec A. Here sec A plus 1 divided by sec A. Here R H S equal to L H S. Here proved. Now we will start question number 5. Prove the following identities where the angles involved are acute angles for which the expression are defined. Cos A minus sin A plus 1 divided by cos A plus sin A minus 1. Now we'll take solution here. LHS cos A minus sin A plus 1 divide cos A plus sin A minus 1. We divide numerator and denominator by sin A. Here cos A divided by sin A minus sin A divided by sin A plus 1 bata sin A. Now cos A divided by sin A plus sin A divided by sin A minus 1 bata sin A. Here cot A minus 1 plus cosec A divide by cot A plus 1 minus cosec A. Now cot A plus cosec A minus 1 divide by cot A plus minus cosec A plus 1. Now cosec square A minus cot square A equal to 1. Cot A plus cosec A minus cosec square A minus cot square A divide by cot A minus cot A plus cosec A minus cosec A plus cot A cosec A minus cot A divide by cot A minus cosec A. I take this common, cot A plus cosec A. 1 minus cosec A plus cot A divided by cot A minus cosec A plus 1. Here this one cutting. Now cosec A plus cot A proved LHS equal to RHS. Question 6. Prove the following identities where the angles involved are acute angles for which the expression are defined. Under root 1 plus sine A 1 minus sine A equal to sec A plus tan A. Solution. LHS left hand side 1 plus sine A divided by 1 minus sine A multiplying and dividing by under root 1 plus sine A. Here 1 plus sine A divided by 1 minus sine A into 1 plus sine A 1 minus sine A. Here 1 plus sine A whole square divided by 1 minus sine square A under root. Here cos square A 1 minus sine square A. We know this one. Now 1 plus sine A whole square divided by cos square A 1 plus sine A divided by cos A. Here 1 by cos A plus sine A divided by cos A. Here sec A plus tan A LHS equal to RHS. Now prove the following identities where the angles involved are acute angles for which the expressions are defined. Sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta equal to tan theta. Solution. LHS left hand side sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. Now common sin theta, we take this one here, 1 minus 2 sin square theta. Now here cos theta, here 2 cos square theta minus 1. Here sin theta, 1 minus 2 sin square theta, divide by cos theta. Here 2 1 minus sin square theta. We know this one, cos square theta 1 minus sin square theta. Now sin theta 1 minus 2 sin square theta divided by cos theta. Here 2 sin square theta minus 1. Here sin theta 1 minus 2 sin square theta divide by cos theta. One minus 2 sin square theta. Here tan theta. LHS equal to RHS. Proved. Now prove the following identities where the angles involved are acute angles for which the expressions are defined. Sin A plus cosec whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. Now solution here. LHS sin A plus cosec A whole square plus cos A plus sec A whole square. Here sin square A plus cosec square A plus 2 sin A into cosec A plus cos square A plus sec square A plus 2 cos A into sec A. Here sin square A plus cosec. We know that cosec square A minus cot square A equal to 1. Here cosec square A 1 plus cot square A. Here we can write 1 plus cot square A. Here 2 sin A into 1 बटा sin A plus cos square A. We know that sec square A minus tan square A equal to 1 plus 1 plus tan square A plus 2 cos A 1 by cos A. Here cutting this one, sin square A here plus cos square A. Now 2 1 plus cot square A one plus 2 plus tan square A. Now here 1 2 plus 1 1 to 1 here 1 plus 2. Now tan square A plus cot square A. Here 7 plus tan square A plus cot square A. LHS plus equal to RHS. Proved. Finish this one. Question. Prove the following identities where the angles involved are equate angles for which the expression are defined. Cosec A minus sin A, sec A minus cos A. Prove this one. Equal to 1 divided by tan A cot A. Now solution. Here LHS cosec A minus sin A sec A minus cos A 1 by sin A minus sin A cos A minus cos A. Sin square A. Now cos A LCM here 1 minus cos square A. Here cos square A divided by sin A. Sin square A divided by cos A. If here cos A into sin A, cos A into sin A divided by sin square A plus cos square A. We know that sin square A plus cos square A equal to 1. Now, sin A cos A divide by sin A into cos A. Now, sin square A plus cos square A divide by sin A into cos A. Here 1 divide by sin square A divide by sin A into cos A plus cos square A divide by sin A into cos A. Sin here 1 divide by tan A plus cot A. Here 1 divide by tan A plus cot A. LHS equal to RHS. Prove the following identities where the angles involved are acute angles for which the expressions are defined. Solution. LHS 1 plus tan square A divided by 1 plus cot square A. 1 plus tan square A 1 plus 1 bata tan square A. 1 plus tan square A here tan square A tan square A plus 1. Here this is cutting. Here tan square A L H S R H S. Now 1 minus tan A 1 minus cot A whole square. 1 minus tan A divided by 1 minus 1 bata tan A whole square. 1 minus tan A here tan A minus 1 here whole square. Now 1 minus tan A here divided by 1 minus tan A divided by tan here minus tan here tan square A. Prove this one.